So, good evening, everyone. So, let us start today's session. Okay. So, can you able to see my screen? Okay. Multidimensional arrays in CPU in CUDA. Uh, the next one is how can we start with PyCUDA? Okay, so since the single dimension is very easy, normally all the data are stored in GPU in continuous memory location. Okay, so here how we can write multidimensional arrays using CUDA. Okay, so you all know that what we can do with matrix squaring. Okay, so if you are having some two-dimensional matrix, in the sense what you have to do, you have to get the row value and the column value and row index and the column index. After that, you have to get that particular value, then multiply it with the same value. Okay, that happens in matrix squaring in CPU. So automatically, you need three for loops. Okay, the time complexity is very high. Here, you'll be getting some order of n cube. Okay, so here, so for example, if you can give a matrix size as 32, okay, we will be having 32 cross 32 matrix. Okay, and all the 32 cross 32, 32 into 32 elements have to be squared. Okay, so you know this code very well. So next, how we can do it there in GPU. Okay, so the kernel program is written here. Okay, so you include the input and output statements in the main program along with the kernel launch. Okay, so that's very simple only. And see here, squaring the matrix elements. Okay, here what we got use this, we are using both block ID and thread ID. Okay, so finding the index of all the elements and the which are stored sequentially in the GPU. So II and JJ is calculated. So II is calculated as ID divided by matrix size and JJ is ID modulo division matrix size. Okay, here we will be getting some what is called quotient, and here you will be getting some remainder. Okay, so next one for loop is used. Okay, so in that particular for loop, in what way we are calculating uh, matrix squaring in CPU will be performed here. Okay, so in that way you can perform here. Okay, that is a one method. So another one method is, okay, so here in that particular main program, two-dimensional matrix have been defined. So and how many blocks per thread, how many thread per block. So everything is defined. So you can do CUDA mem copy to copy from CPU to GPU. Okay, both the matrices. Then it is called. After that, we are printing the results. Okay. So here in this particular program, the input and output is not given. You simply write. So you can write in this way except this dim blocks. Okay. So here in block per grid and thread per grid, you can give some numbers. Okay. So n is passed here. That is the size of the array. And here what happens is, in here we are using two-dimensional matrix. So both x and y direction have been used here. So for the x direction, you calculate the index, and y direction, you calculate the index. After that, what you can do is you multiply both the things. Okay, that's all. So you will be getting the matrix query. Okay. So the optimized one is you calculate uh, index in x direction and index in y direction. Okay. So after that, you do perform this one. Okay. So next, we'll see what is PyCUDA. Okay. So already we have already you know that. So the CUDA API, so that can be programmed with the help of C, C++, and Fortran, Python, okay, etc. So here we can see how PyCUDA is used for writing codes in GPU. Okay. So here, what is the main difference between C and Python is, so in Python, you can have a lot of data visualization and scientific computing. Okay, so I don't know who are all are familiar with Python. Anyhow, uh, so here, while using PyCUDA, what the main thing you have to do is, so the kernel program and all written in C only. Okay, so what you have to do in there in the GPU, that is the thread IDX and block IDX, everything when written a C code. Okay, that will be embedded inside the Python. Okay, so all the remaining things are same in the as like a Python. Okay, so here while using Python, the QL is very much improved. So with respect to your data visualization and scientific computing. Okay, if you want to execute some Python program for large amount of data, that time you parallelize those data and can run on GPU. Okay. So this CUDA program compilation workflow. Okay. So you'll be having some GPU source module. Okay. So that is gone to or executed with the help of PyCUDA, and GPU binary is it's converted. That is, GPU source module is converted into GPU binary. So, and it is compiled using GPU compiler. Okay, and everything is uploaded into GPU, and it is executed. Okay, if it is having GPU model, it goes to the GPU for its execution. Okay, so already I told you, you are having some Python, and you have to integrate that particular GPU model inside the Python. Okay. So here, what you need is, you need the Python 3, and you need hardware accelerator. Okay, you need the code cell. Already you know that. Okay, what are the things there in the Colab. Okay, and PyCUDA is not a native library in Colab, so we have to install PyCUDA before importing any other libraries in that particular cell. So I think you can able to see my screen. Change the runtime to T4, then you install this. Pip install PyCUDA. So anybody is executing, you can use the code there in the chat. So it takes some 1 minute's time for its installation. If once the session is terminated, so it won't be saved there. The PyCUDA is, you have to install it again because it is not the native library. Okay. Okay. So it is enough to install PyCUDA. No other thing is needed. And so the basic libraries required for executing PyCUDA programs are and PyCUDA.driver, PyCUDA.autoinit, PyCUDA.compiler. Okay, so again, you need some source module. Okay, these are all the three things. Okay, so you have to import PyCUDA.autoinit from PyCUDA.compiler, and also you have to import source module. Okay, these are the three things. Let us see whether it is completed or not. So here internet is a little bit slow. Again, it is not said, it means. Okay. So it is installed. Says requirement already satisfied. It is installed. So after that, so here you can see here you have to import three things. So here you are displaying some basic things. Okay, so import both the things, and what the next statement is uh, number of devices found CUDA.device.count. Okay, so it will display the number of devices found, and CUDA.device of 0, that will be stored in DEV. Then we are printing that dev dot name. Dev, this variable we have used. Okay, so like normal Python, uh, so there is no need to declare the variable and all. And compute capability you can print. And what is the total memory? And so you can also get the attributes of that particular device. Okay, so you can sort and so you can print all those things. Okay, if you have used any CUDA related statements, so you have to prefix that with some percentage symbol. Okay, so I'll execute. So it is executed. So one device is, that is only one device is there. See here, the runtime type, you have chosen only one device. and the device name is T4. Okay, so the compute capability is 7.5 floating point operations flops per second. Okay, what is the total size of the memory? What are the other parameters of or attributes of this particular device? Okay, what is the clock rate? Major compute capability, minor capability, compute mode, compute preemption supported, kernels. Okay, so all those things are the parameters or attributes. Okay, so all the attributes have been printed. So here we can see that PCI bus ID is 0. Okay, so we are using some GPU in the cloud. We are not using what is called uh, any GPU inside our system. Okay, so there is no need of PCI bus. Usually, GPU is connected with our motherboard, system motherboard, with the help of PCI bus. Okay, so these things are given as 0. Okay. Okay. So here already we have seen matrices. Okay. In Python also we can use matrices. So for using matrices, we have to use NumPy and all. Okay. See, NumPy, random numbers, random of 5 comma 5. Okay. So the array is 5 comma 5. It will take the random values. So NumPy dot float. That is your values have been converted into float 32. Okay. Okay, so already we know that if you have used any variable in your program, that that variable won't be accessed there in GPU. What we have to do is while writing C program, so you have to allocate memory for that variable in GPU. After that, you have to transfer all the values from CPU to GPU. Okay, all those things you have to do it here itself. Okay, and so what you have to do is, okay, so you can allocate memory. Okay, so if there are two variables means A and B, so both A and B has to be allocated. Okay, in this format. And HTOD, memcopy HTOD, host to device. Okay, so host to device a GPU, comma A. Okay, so the variable in CPU is A, GPU is A GPU. Okay, so you have to use this particular statement, and for change copying B, the same statement you have to use. Okay, and if you want to copy it from GPU to CPU, you have to use the reverse of that particular command. So after that, the main part, okay, how will you write the kernel? Okay, so for writing kernel, what you have to do is you can write inside that particular source module. Okay, so inside the source module, entire kernel will be a argument of source module. Okay, the same format as we have written in the CUDA C. Okay, go global void add. So we are using two variables. So we are using the thread IDX and block IDX. Okay, and we are adding both of things. Okay, so A and B both are added together and stored it there in A itself. Okay, Let us see. Okay. So here in this particular program, anybody needed this program? I didn't paste this one. It's not copied. Okay. So in the next program also you have to do first you have to import the auto unit. After that you have to import PyCUDA driver. Okay. And if you are using NumPy, you have to import it. So from PyCUDA compiler, you have to import source module. Okay. See here, this three variables have been used. Okay, A and B is added and stored there in DEST. Okay. So the thread IDX here it is having only the thread IDX. Okay. So it is stored in some variable thread IDX. Then destination I equal to A into B. Both A and B is multiplied and store it there in the DEST. So next is we are having two variables A and B. So numpy dot random of 10 that is converted into float. Again B that is converted into float. Okay. So here what we are using is and output will be stored in DST and in A and in B. So you are having block 3-dimensional 400 comma 1 comma 1 and grid 1 comma 1. Okay. So launching the kernel in this way. Okay, multiply the DRV. What is DRV? The PyCUDA driver. Okay, and output is there in DST. One input is in variable A and one input is in variable B. So how many blocks? How many grids? Okay, and you are printing dest A star B. Okay. So you'll be getting that result. While writing PyCUDA programs, you need to know something related with Python, NumPy and all. Okay. Uh, so we don't have any basic session about Python. Okay. People, if you are familiar with Python and NumPy, you can able to write the code. DRV out and DRV in. Comma is also missing. Anybody is executing the program? No? Okay. So if you are executing means you try in this way also. How you can do it for both thread and blocks. Okay. Okay, so already we have seen this how the index is calculated because in GPU you are having the linear array. So likewise also here the index is calculated. Okay, so you know that already. So thread ADX is referred to x direction, thread x is y dot y is which is for y direction, and block dimension. So in here in this case the block dimension is 5. Okay. So what is block dimension? Anyone? Block dimension. What is it? Any idea? No. Block dimension is nothing but number of threads in that particular block. Okay. And so here you can create the one dimensional or two dimensional array. If you are using only thread IDX, it is a one dimensional. If you are using both in x and y direction or both thread and block, it is in two dimensional. Okay. So you can also create separate variable to say, get the function. Okay. So module dot get function of add, and here you can give like effects of a GPU, B GPU, your block equal to what is your block. Likewise, also you can give. So, what it will do is it will extract the function from source module. So and execute it on the GPU. Okay. So what is the with the help of the copies of A and B. Okay. So normally in CUDA C programs, what you will do is you will write the kernel code. After that, you simply launch the kernel. Okay, so that is enough. But in CUDA programs, see you are writing the same kernel, but launching is little bit different, not as same as that of your CUDA C. Okay, you get that function from the kernel. So with the help of that, you will choose how many blocks are you are going to use. Otherwise, how many threads or how many grids. Likewise, you can give. Okay, so in that extracting the function from source module, after extraction of the functions from source module, in the sense within source module only we are writing the kernel code. Okay, so after that you have to give the variables there in the GPU, and how many threads, blocks, and all you are going to use. Yeah, all those things you give for the execution. So next is extracting the result. It is also different from actual CUDA C program, and So you create some different matrix and you copy those things from what is called device to host. Okay, host is your CPU, device is GPU. That statement is DTOH. Okay, device to host. Okay, add equal to numpy dot empty like A and CUDA dot memcopy DTOH add comma A GPU. Okay, so that is the statement you have used for copying your results from GPU to CPU. So you can see some of the things from the output matrices. Okay. So if you are using NumPy, that is a NumPy array, can get. Okay. So with the help of parallel programming, so you will get some faster execution, and you are executing, you are performing repeated computation. With the help of repeated computation, you will get some faster execution. So you can handle the data efficiently, and so it doesn't need high power machines in comparison to CPU. So if you are doing parallelization in CPU means we need some high power machines. Okay. So while considering GPU, so if you have some small workstations, you can do some bigger problem with a lot amount of data. Okay. And normally, parallel programming may be applied in some scientific computing and all. And okay, we'll see some more things which are. And the references is there is one tutorial is available in online. Okay, through that you can get more information. 1 minute, please. Okay, so here what we can do is computer and you will be getting. So here what we are doing is we are creating one random okay return. Okay, double the value radius dot x plus thread radius dot y into multiplied by 4 and it is stored in idx and function is called that is our kernel function. You have to extract get underscore function of w5. Okay, then what you have to do is you have to use allocated in GPU. So and we are using the block 4 comma 4 comma 1 block in the sense the value a will be stored then a double and the a double is stored in a double and particular function is used that we are printing the result is stored in so we are printing that particular result. After that, a value is printed. See here 3162. Okay, that is doubled here. Okay. In this way also you can what you can do is you can launch the card. So instead of giving also works. So in any way you can do. So you can write it in single cell, or all the entire program can be written as single cell. Okay, so both your root there. Device allocation in out of thread context. Not okay. They couldn't clean up like that. It says. Okay, so there are some other statements and some other drivers are also available. PyCUDA driver.in, PyCUDA driver.out. Okay, so instead of giving what is called, so here what you have given us, so it is get using the get function, we are getting that particular kernel function. After that, you are calling the kernel is launched. Okay, so for that, what you can do is you can use instead of writing in this way. Okay, in this way, CUDA dot in out a block 4 comma 4 comma 1. Okay, for that, what you have to do is you have to use this combined use. So what it will do is it will simplify some memory transfer. Okay, and instead of creating a GPU, there is no need to create a GPU and allocate memory directly. You use a. Okay, so you and send the value to GPU. Okay, so likewise also you can use if you replace that one. So also you have to include these drivers. Okay, and and the function invocation also done with the help of some other method. We're having built-in pydriver dot pycuda dot driver dot function dot underscore underscore call underscore underscore, that method. Okay, so this method also you can use. And um, see, if you want to achieve some sort of mm, function, if you want to remove the overhead, okay, I'll execute in the code. You want to remove some overhead, so you can use this particular built-in, okay, for its execution. See here. So instead of, there are many methods are there. Okay, you give the grid. Okay, how many blocks you needed, that will be given in grid. How many threads you needed, that will be given in block. Okay, and prepared call. Okay, that is a function. You can give grid block and the variable going to execute. And also you can use GPU array. Okay, so instead of using NumPy, you can use GPU array. So a underscore GPU equal to GPU array dot to GPU NumPy random dot random 4 comma 4, and it is converted to float. Okay, so a double equal to 2 into a GPU dot get, and after that you can print that. So you print that. Okay, so in that particular program, this program, what you can do is you can change this code, these codes to this, but you have to include the pycuda.gpu array for using this. Some other advanced topics are also available. You can use structure. So this was contributed by some Nicholas Dunn. And within the source module, you can use structure. Okay. So here, after that, you will be using the kernel function. Okay. For the same code for double array. So So instead of one array, you can use two arrays too. Okay. And so whatever the function you are using in Python, you can use it here. Okay, self function, everything. You can use it here. Okay, class. So this is the first array, this is the second array. So you can print array 1 and 2. So for using this code, what you have to do is you have to import this driver and from uh, driver to device and driver dot from device function. Okay, these functions should be used to allocate copy values and mm, from to and from your GPU and CPU. Okay, so it's also for doubling the array. Okay, so you are using structure array, you are using block, and so here also what you are doing, you are extracting the kernel function from the source module. Okay, so after that this is called, then you can print it. Okay, so instead of using CUDA array, you can use CUPy. Okay, you can use it also. CUPy is another one type of array, and CUPy A. Okay, that is the array. Then the same double function. So they are extracting that kernel function, and they are calling that function. Okay, and here the PyCUDA GPU array, what it will use is it will use it can also use number kernel. Okay, from number import CUDA. So here also you can what you can do is you can define the array. Okay, so you can get the array in A underscore GPU. After that, you can write the function for doubling the array. Okay, so ij equal to CUDA dot grid of 2, that is two dimensional, x of ij into equal to 2, doubling the array. Okay, so for that here you are using the function double and grid and block. So you have to pass where uh, where the that particular array is stored. Okay, so these are all the different types. If you are having some bigger arrays and two-dimensional arrays or multi-dimensional arrays to execute, after that you want to visualize properly, that time you can use PyCUDA effectively, and you will get some visualization based on the results you have obtained. Okay, so otherwise what you have to do is you have, if you are using only CUDA means you execute and you get the result. After that you go with some other visualization techniques, then you visualize. Okay, while using PyCUDA, you directly do that. But the main concept is same. They're in CPU and the that is CUDA C and in PyCUDA. I think you got something related with PyCUDA. So any doubt? Suppose these materials also there in that particular sheet. You make use of those materials. And the debugging notepad. So I'll update that notepad and I also I'll upload there in the sheet. Okay. So thank you everyone. Okay, thanks for your patient listening for all these 15 days.
Ma'am,
Yes.
hello. Yeah, ma'am, I have one
Yeah,
query.
yeah,
Okay. Uh,
yeah.
Suppose, like, if I have some model, okay, which is currently running on, suppose, B CPU, which have, around 32 gig, okay, matlab CPU. Now,
Okay.
it has two instances, two GPU, 32 GP, 32 GPU. Now, if
Hmm.
I want to go a little bit higher version and I am providing, maybe 64 GPU, B GPU, B CPU,
Hmm.
will
Hmm.
it able to handle, load of these two, individual that separate GPU, like bandwidth and all?
It is based on the compute capability of the new GPU.
Okay.
Okay, it is based on the compute capability of that particular GPU. If
Okay.
it has some uh,
Okay.
having some higher number of cores, then it may execute in very faster manner. Then you can achieve
Mm-hmm.
the performance of all the GPUs in that single GPU.
Okay. Suppose if I have, currently like NVIDIA provide now, like if I have 12x large, okay, GPU, and I want to
Okay,
shift from that to, like 16 or like higher version, okay. I have two
okay.
smaller version and I want to, go for higher. So now that
Okay.
bandwidth and all, okay, will it that one version will able to handle it?
Actually, if you are having more than one GPU, so you can connect it
Yes,
with
ma'am.
using some NV-Link. So that
ND-Link.
connection,
Okay.
yeah. You are having the separate. Normally, for connecting the computers, there will be some switches or bus. Everything is routers are used. No, okay. There are
Mm-hmm.
for
Okay.
connecting the different GPUs in a single machine. So you are having some other devices available. Okay, if you go with that, then you will get that is communication will be very faster and you will be getting some results quickly. So instead of connecting some other way, okay. So if you are connecting in PCI Express slots alone, it won't give some better results if you are
Okay.
having multiple
Okay.
GPU.
Mm-hmm.
Actually, different vendors are providing uh, filter. So NVLink is another one bridge that is used for GPU interconnect. NVLink.
Okay.
Okay. So if you want to connect more than one GPU, that time you'll go with some NVLink. See, the NVLink is provided by NVIDIA itself. and some Mellanox, some other vendors are available for connecting multiple GPUs.
Okay. Okay. Thank you, ma'am.
Okay, thank you. So thank you once again.